Hey guys, this is lesson 12.7 for pre-algebra. It is titled Experimental Probability. So it's just that. It's doing an experiment, seeing how many times you can shoot the basketball, make it. It's just all different experiments and then the probability based on the experiment. So in your notes, write down this key concept is probability based on experimental data. So the probability of an event happening, it's written like this with the P of the event. So the probability that I make my free throw is the number of times that I make it the number of times an event occurs divided by the number of times I try. So if I go to a basketball court and I shoot 20 baskets or free throws and I make 8 of them, my probability of making a free throw would be 8 out of 20 or 40%. So it's exactly what they use for professional sports. Baseball batting averages are figured out by the number of times they hit the ball out of the number of times they get up to bat. Or, like free throw percentage is all based on experimental probability. It's different for every person because every person shoots the ball differently or hits the ball differently, but it's all based on what you actually do. So here's an example. It says, a medical study tests a new medicine on 3,500 people. It is effective for 3,010 people. Find the experimental probability that the medicine is effective. Then predict the number of people in a group of 6,000 for whom the medicine will be effective. So first I need to figure out the probability of the event, which is the number of times an event occurs divided by the number of times the experiment is done. So I'm going to start with 3,010 people. That goes on the top. And I'm going to divide it by the total number of people that got the medicine. And then I divide them on my calculator. I get 0.86 or 86%. So this medicine is 86% effective. They do this all the time. So the medicine will be effective for, and then you do 0.86 times 6,000. So this means that 5,160 people would benefit from the medicine because it would be effective for that many people. So try this one. It's just another example. So try this one on your own. Push pause, and then we'll go over it. Okay, so another medicine is effective for 1,183 of 2275. So you're going to do 1,183 divided by 2275. And that equals 0.52 or 52%. Find the experimental probability that the medicine is effective. Then predict the number of people in a group of 4,500 for whom the medicine will be effective. So then I take this number, 0.52 or 52%, and I multiply it by 4,500. And that equals 2,340 people the medicine would be effective for. All right, so let's try some more examples. A simulation is a model used to find experimental probability. So if I do a simulation, I would actually do the experiment. I'd go outside and shoot 20 baskets or just anything that you would do. So it says, students were surveyed about the number of pencils in their book bags. The table shows the results. Write each experimental probability as a fraction in simplest form. So here is the survey, and this is an experiment. It's an experiment because every single person I would survey probably would have a different result of how many pencils they had in their backpack. So they just surveyed the kids in their class. So try these 4 problems, push pause, and then we will go over it. All right, so what's the probability of having 1 pencil? So here's 1 pencil right here, and that's 16. So I'm going to do 16. Now I need to figure out the total. So I'm going to add them all up. Well, 16 plus 4 is 20, plus 12 is 32. 16 over 32 is 1/2. They didn't want it as a percent, they wanted it as a fraction in simplest form. So what's the probability of no pencils? Would be 4 out of 32, which is 1/8. And the probability of 2 or more pencils would be 12 out of 32. If I divide them both by half, would be 6 over 16, and then I can do 3 over 8. And then lastly, what's the probability of at least 1 pencil? So that would be both of these, at least 1. So that would be 28 over 32. So I just keep cutting them in half. 14 over 16, 7 over 8. All right, that is it for your notes.